we've seen a skill shortage in PCB layout area, so I think actually more and more engineers are being involved in actually doing the PCB layout, which is not their skill set. There's a skill to PCB layout which they may not have, and also it's not probably what they want to do. They want to do the engineering side of it. So why not use a machine to plug that gap and allow the engineer to be creative and create the product, which is what they want to do at the end of the day, and take out all the bits that they don't want to do and make that automatic. And one way to do that is obviously to use AI to try to model what the current layout engineers do in the design process. You've got things like ChatGPT, which people sometimes find a benefit. You've got things like Stable Diffusion for generating images. So we're in the sort of generative space looking at PCBs. But in particular, with the real difficulty, the problem we're looking at is you need that creativity of ChatGPT. You need, but you also need accuracy and precision. Those three things to work together in an engineering space, and to do those in the PCB design in particular is quite tricky because of the sort of multimodal nature of the data that's involved in it. There's text data, there's numerical data, there's geometric data, there's hierarchical information. So there's all these things in there. And of course, the other problem with PCB in particular is there's not very much data. It's not like you can take, with ChatGPT, the whole corpus of text on the internet and train a model based on that. You just don't have that. So you have to come up with new techniques for extracting as much information as possible from a small set of designs, and being able to sort of boil that down in a way that you can then apply that information to new designs. Again, you're not just saying generate me some text, you're saying apply what you've learned to some new constrained design that I am going to provide you with. So it's quite a different sort of process from, say, some of the current state-of-the-art general AI. We're announcing our new product, which is the AI Place and Route tool, and it's the first release of that. So it's part of a longer roadmap to ultimately provide automation that in the tool that would have traditionally been, we've had automation for many decades. Of course, we've had auto routers and auto placement tools, but this is approaching it in a completely different way. It's trying to approach it in the way that a designer would approach it. So it's not treating it as an individual task. It's looking at the whole design process holistically and tackling it as a planning problem, as a design planning problem in a hierarchical way. So it's a completely different way of approaching the design process in terms of automation. Ultimately, we have a number of different products. The first one we're releasing now is just the sort of foundational product. It's just auto routing at the moment, and it's something called the basic brain, which is Zuken trained. We've used designs from Zuken to train this data. The next product is called the dynamic brain, which will then allow customers to train using their own data and extract information from their own designs, and then reapply that to new designs that they're working on. But the ultimate goal, the overarching sort of story of this is the autonomous brain, which is when the AI does exploration and it learns for itself and it tries to measure how successful it was and tries different things. So it's really, the first two are learning from the data. The last one is exploration, and this is where new techniques might come up, something that, the first two you're sort of limited to what you've seen before, but the last stage is, well, now let's try and push the boundaries and see what other new things we can come up with. And one way to think of those three products is, Zuken trained brain, customer trained brain, and AI trained brain. So that's the three sort of levels we're talking about there.